In this video, I'll be going through the Cedar Girls Secondary School Chemistry Paper 1 Prelim paper for 2023. So let's get started. So now in the first question, you are given diagram 1 shows the paper chromatogram of substance X. So this is X, and when it undergoes paper chromatography, we know that it can be split into Y and R. So from here, we know that X is a mixture. Okay, so we know that X is a mixture. So therefore, if we look at the options A, B, C, and D, we can eliminate B and D because X is not pure because it's made of Y and R. Next, diagram 2 shows the cooling curve for substance Y. So if you take a look at the cooling curve for substance Y, we know that this is substance Y, and here it is occurring at a fixed temperature, and this is when it undergoes a phase change. Okay, so if Y is a liquid, in other words, it is freezing to form a solid here. So in other words, right, this is the freezing point, and whenever you have a fixed temperature for phase change like freezing, melting, boiling, or condensation, is an indication that the substance is pure. So therefore, we can conclude that Y is pure, and therefore the answer option is A because we know that X is a mixture while Y is pure. Moving on to question 2. A drop of liquid bromine is placed in the bottom of a gas jar. Brown fumes of bromine vapor slowly spreads through the covered gas jar. Why does this happen? So once you see this is the diffusion experiment that we learned at the beginning of the O-level chemistry syllabus. So let's draw this. Okay, so this is a gas jar. So maybe I'll put a crucible that contains bromine. Okay, so this is the drop of bromine that we have. Okay, then I also have the gas jar. Okay, so let me draw out the gas jar here. So something like this. Okay. So the bromine gas will slowly vaporize. Okay, after it vaporizes, it fills up the entire gas jar. So you see that the entire gas jar is now brown in color. Okay, so why does this happen? So bromine gas is not less dense than air. In fact, it is denser than air. Okay, this is wrong. So if you're wondering why is bromine gas denser than air, well, let's take a look at the periodic table, which is found at the end of this. So bromine exists as Br2. So if you were to calculate the MR of Br2, it will be 80 times 2, which is 160. Air is made up of mainly nitrogen. Okay, so if you were to look at the MR of nitrogen, okay, it is 14 times 2, which is 28. Okay, so most of it is nitrogen. There's some oxygen. So the average MR of air is usually around 30. Okay, but if you were to compare the MR of bromine and compare that with nitrogen, which is 28, it is way above the MR of nitrogen. So the higher the MR of a gas, the denser it is. So bromine is denser than air. Okay, so because it is way more than 28. So this is incorrect. Okay, so let me go back to. So this bromine is less dense than air is incorrect. Bromine is denser than air, and to find whether something is denser or less dense for gas, we'll compare MR. Moving on to B, bromine molecules and the molecules in the air are always moving around. Yes, they are always moving around because for gas particles, they are always moving around. Okay, so B, correct. But let's check C as well as D. Bromine molecules are smaller than the molecules in air. No, the size of the molecule depends on many factors. But for your syllabus, you can just count the number of shells of electrons, number of shells occupied by electrons. So we can take a look again at the periodic table. Okay, and for air, we will use nitrogen as reference because nitrogen and oxygen, they are all in the same period of the periodic table. Then bromine is here. So nitrogen is in the second period. So in the second period, there are 2 shells filled with electrons. Okay, bromine is in 1, 2, 3, 4, fourth period. So there are 4 shells filled with electrons. So if you look at bromine, it has 4 shells filled with electrons. 1 shell, 2 shell, 3 shell, 4 shell, right? Okay, then you need to draw in the electrons. Okay, then nitrogen, it only has 2 shells filled with electrons. Okay, so in other words, right, bromine is bigger, the molecule size is bigger compared to the size of nitrogen. Okay, so because of this, okay, bromine is bigger. The molecule of bromine is bigger than the molecules in air, which we use nitrogen as a reference. So therefore, C is wrong. Okay, bromine molecules move faster than the molecules in air. This is also incorrect. Okay, so generally, the bigger the molecule, the slower they move. Okay, there is something known as kinetic energy, which if you take physics, you learn. So kinetic energy is equals to half mv square. For the same temperature, the molecules have the same average kinetic energy. The average kinetic energy of the molecules are the same. So in order to have the same average kinetic energy, the higher the molecular mass, the lower the velocity. Okay, but that is not true. So the answer is B. So the molecules, the bromine molecules and the molecules in the air, they are always moving around. So therefore, at the end of the day, right, the bromine molecules and the air molecules, they are evenly distributed around this gas jar, and therefore you see brown fumes of vapor all around this gas jar. Okay, so this is actually testing on diffusion. So after some time, all the bromine molecules will fill up the entire jar. All the air molecules will also be filling up the entire jar. Okay, but air is invisible, it is colorless, and we can't see it at all. So therefore, we use things that are colored like bromine to observe. All right. Okay, now moving on to question 3. Aqueous silver nitrate is added to aqueous barium iodide until no more precipitate forms. The precipitate is filtered off. Dilute sulfuric acid is added to the filtrate until no more precipitate is formed. The precipitate is filtered off. So let's look at it. So we start off with silver nitrate and we add it to barium iodide. So remember, silver iodide is insoluble. Okay, so we have silver iodide being formed as the precipitate. Okay. Next, they will also add sulfuric acid until no more precipitate is formed. So you'll be wondering, what is sulfuric acid used for? So whenever you see the word precipitate, okay, I want you to think of insoluble substances. So let's look at here. So the first sentence here, you have silver, you have nitrate, you have barium, you have iodide. Okay, so think of what is insoluble and what can mix together to be insoluble. So you start off with silver nitrate, right? You won't get silver nitrate again. Okay, and you don't have cations combining with cations, so you cannot have silver barium. You also cannot have anions combining with anions, so you cannot have nitrate iodide, right? So you have silver nitrate and barium iodide. So the product formed during precipitation is basically they swap their partners or their anions. So silver will combine with iodide and barium will combine with nitrate. So if you have to look at the solubility table, okay, that you have learned. So I'll provide the link in the description below for the solubility table if you're interested. So if you look at nitrates, all nitrates are soluble. So we know that definitely the nitrate that is being formed, the barium nitrate form, is definitely not the precipitate. Okay, next we look at the chlorides, okay, which will also apply for your iodides as well as your bromides. Okay, so all your chlorides, bromides, and iodides, right, they are all soluble except for lead and silver. So if you to look at this, we know that, oh, silver iodide is insoluble. So that is the precipitate we are looking at. Okay, so the first part here, the precipitate that we are looking at here is barium iodide. Sorry, is silver iodide. So this precipitate here is silver iodide. Next, you have dilute sulfuric acid. So if you have dilute sulfuric acid added, you have a sulfate ion that is added. Okay, and you add more precipitate. So let's take a look at the solubility table again, and let's look at sulfate. What sulfate is insoluble? Well, you have barium sulfate and lead 2 sulfate. And if you have to look here, so initially we have silver and barium ions. So in other words, this dilute sulfuric acid, right, is going to precipitate out your barium sulfate. Okay, so in other words, we know that in the first part, the precipitate is silver iodide. The second part, because we add sulfate and a precipitate is formed, therefore we know that we are precipitating out a sulfate salt that is insoluble, and from here we know that it's either barium or lead. But because we did not add lead inside here at all, so it must be barium sulfate. So now we know that it is silver iodide and barium sulfate that are the precipitate. Let's take a look at the statements here. Both precipitates are soluble in excess aqueous sodium hydroxide. Okay, so no, silver iodide is not soluble in excess sodium hydroxide. How about barium sulfate? Well, we'll think about barium hydroxide. Is barium hydroxide soluble? Yes, it is soluble. So it is true for barium. So barium sulfate will dissolve in excess sodium hydroxide, but not silver iodide. So A is wrong. Both precipitates are white. No, silver iodide is yellow. You learned that in your QA chapter. Barium sulfate is white. So this is also out. Effervescence is observed in the second experiment. In order for an acid to give out effervescence, the two types of effervescence is either hydrogen, when the acid react with matter, but it won't be called an effervescence. It will called be bubbles, because when you add a solid to a liquid, okay, the bubbles, so you have gas that is being formed when you add matter to sulfuric acid or carbonate to sulfuric acid. But we do not have any carbonate being added. We do not have any matter being added, so C is not correct. Okay, the nitric acid is present in the filtrate after the second experiment. Okay, so now let's take a look at this, right? So in the first experiment, the first sentence here, we actually form silver nitrate and barium iodide. Sorry, we react silver nitrate with barium iodide to form silver iodide and barium nitrate. Okay, so this is the solid. Then next, the barium nitrate, right, which is the liquid, okay, reacts with H2SO4. So we precipitate out barium sulfate. And if you to look at it, so the barium combines with the sulfate. So the hydrogen ions will combine with the nitrate ions to form nitric acid. So therefore, we agree that nitric acid is present in the filtrate after the second experiment. So therefore, D is the answer for question 3. Next, let's move on to question 4. Which graph shows the number of electrons in the outer shell of an atom plotted against the proton number for the first 10 elements in the periodic table? So they ask for outer shell, number of electrons in the outer shell. So to determine the number of electrons in the outer shell, you just need to look at the group number. If it's in group 1, that means there's 1 valence electrons in the outermost shell. If it's group 2, 2 valence electrons in the outermost shell. Okay, so therefore, one thing that we are sure of is we do not have this because we do not have group 10. if there are 10 valence electrons in the outer shell, it means that it's group 10, but there's no group 10 in your periodic table, right? It's only until group 8. So we know that A and B are out. So it's either C or D. All right, so let's take a look. Okay, basically, right, if you look at this, right, it's quite certain that D is also out, and the answer is C. So let me explain why C is definitely out. So let's take a look at the periodic table first. So if you look at this, right, we start off with 2 valence electrons. Helium has 2 valence electrons. It's the only element in group 0 or group 8 that has 2 valence electrons. Okay, after 2 valence electrons here, this is group 1. So lithium has 1 valence electrons. Then beryllium 2 valence electrons. Then boron is 3. Then 4. Then 5. Then 6, 7, 8. So we know that the number of valence electrons, right, from the proton number of 2, we can also have 1. So for 1, which is hydrogen has only 1 valence electrons because it only has 1 electrons, right? So for hydrogen, so if you have a proton number, okay, and when it's 1, you have 1 valence electrons. So this is proton number. Okay, maybe let me plot it here. Proton number versus the valence electrons. When the proton number is 1, the number of valence electrons is also 1. Excuse me. When the proton number is 2, which is helium, the number of valence electrons is 2. Okay? Then when the proton number is 3, you'll go back to group 1, right? So it is 1 valence electrons again. Then you have 1 valence electrons, 2, 3, 4, 5, 6, 7, 8. Then it goes all the way up, right, until you reach 8. Okay, for neon. So you know that once it reaches 2, it goes down, then it goes up. So therefore, okay, oops. Okay, so it won't go down. So because your elements are arranged in such a way that the number of electrons, the valence electrons increases, then once it reaches group 8, it goes down to 1 valence electrons again. It doesn't go back to group 7 and so on. So therefore, D is definitely out. Okay, so this is the answer and C is the answer. Okay, next, let's move on to question 5. Element X reacts with nitrogen to form an ionic compound X3N2. Which formula for compounds formed by X is correct? So let's take a look at X3N2. Okay, and I also want to go back to the periodic table. Okay, and let me erase some of the items here. Okay, so whenever you have the periodic table, right, in general, okay, what are the charge? We know that group 1 forms ions with charge of +2, group 2 +2, group 3 +3, group 4 don't form ions. Then group 8, very stable, tend not to form ions. Then group 7 has a charge of -1, group 6 charge of -2, and group 5 charge of -3. Alright, so now going back to this question here, we have X and N. So we know that N is in group 5, so it has a charge of 3-. X, I don't know. Right. So now, I know that, right, I form a compound with a formula X3N2. So when you form an ionic compound, is there any charge at the end of the day? No. So I know that 2 of the nitride ions, right, will have the same magnitude but opposite sign of the charge as X. So if I have 2 nitride ions, because it's N2, right, so I know that there are 2 N. So I know that this 2N will have a charge of -6. So in other words, right, this 3X must have a charge of +6. Why +6? This is because +6 - 6 is equal to 0, so that the compound will be uncharged. So I know that 3X will have a charge of +6, so X will have a charge of +2. So X forms an ion with a charge of 2+. Okay, so now I know that X forms a charge of 2+. Okay, now let's take a look at the formula, which formula is correct. So I have X and O. So O is in group 6, right? So O forms an ion with a charge of 2-. So the formula will be XO. Okay, not X2O2. So A is not correct. Sulfur is also in group 6, so the charge of sulfur is 2 minus. So once you put X with S, straight away, no more charge already, right? Because plus 2 minus 2 is 0. So therefore, this is also incorrect. It should be XS, not XS2. Next, we have X and F. So fluorine is in group 7. So if you take a look here, F is in group 7. So group 7 has a charge of -1 for the ions. Okay. And X has a charge of 2 plus. So the formula will be XF2. So you need 2F minus, okay, so that the charge of the F adds up to be -2. Okay, then the whole thing will have no charge. So C is correct. Okay, D is wrong because we know that X and O will form a compound, an ionic compound with a formula of XO. Okay, so D is also wrong. So the answer for 5 is C. Okay, next question question 6. Which compound has both ionic and covalent bonds? So basically, if you see ionic and covalent bonds, right, it's basically an ionic compound that contains these radicals like CO3 2 minus, OH minus, NO3 minus, SO4 2 minus, NH4 plus. Because these are ionic compounds with covalent bonds within them. So your NH4 plus is basically covalent, okay, but there's a charge here. So whenever you see ionic and covalent bonds, just look for a compound that contains ammonium sulfate, carbonate, hydroxide, nitrate. Okay, so the answer is straight away A. Okay, don't get confused with this. Some students confuse sulfide with sulfate. Sulfide, F-I-D-E, is S2 minus. Sulfate, F-A-T-E, then is SO4 2 minus. Okay, so basically when it ends with I-D-E, right, it is by itself, like nitrite, I-D-E. It refers to N3 minus. When you have an ATE, then it is combined with oxygen, like nitrate. Is NO3 minus, that's oxygen. Same thing, sulfide, IDE, basically it's by itself. So sulfide, IDE, so it's S2 minus. Sulfate, ATE, once you have ATE, is an indication that it is combined with oxygen, like our carbonate, sulfate, nitrate, and so on. All right. Okay, moving on to question 7. When a covalent liquid boils, its molecules become widely spaced. Okay, so because from liquid to gas, okay, the particles they gain enough energy to overcome the intermolecular forces that hold them. So the molecules become more widely spaced. So next, which property of the molecule has the most influence on the energy required to boil a covalent liquid? So basically, they are asking you what affects boiling point of a covalent molecule. So you learn that it is the intermolecular forces that affects the boiling point. The stronger the intermolecular forces for covalent liquids, the higher the boiling point. So the answer for 7 is A, because it's the force of attraction between molecules or the intermolecular forces. Okay, moving on to question 28. Question 28 is a calculation question. You have 124 grams of phosphorus vapor has the same volume as 71 grams of chlorine gas at the same temperature and pressure. What is the formula of a molecule of phosphorus? So we do not know what is the formula of phosphorus. Is it P2? Is it P? Is it P2? Is it P4? Is it P8? Okay. Okay, but we are given some information. We know that they have the same volume, okay, as 71 grams of chlorine at the same temperature and pressure. If you have gases and they are of the same volume at the same temperature and pressure, it means that there is the same number of moles. All right. So same number of moles. So what we need to do is, we know that chlorine gas, you have learned, is group 7. They exist as diatomic molecules. So the formula is Cl2. Alright, so I can find the MR of Cl2. Okay, so you make use of your periodic table here. Okay, Cl has a AR of 35.5. So Cl2 will have an MR of 35.5 times 2, which is 71. Okay. Okay, so number of moles in 71 grams of Cl2 is basically 71 over 71, which is 1 mole. So if there is 1 mole of Cl2, then I also know that there is also 1 mole of phosphorus. So the number of moles of P X, because I don't know what is X, is also 1 mole, because same volume at same temperature and pressure means same number of moles of gas. Okay, only apply for gas. Okay, so if you have the same volume of gas at the same temperature and pressure, this means that there's the same number of moles. So I know that there's the same number of moles of chlorine as well as phosphorus gas. So if there's 1 mole of chlorine, there's also going to be 1 mole of phosphorus. So now I know number of moles, I know mass. What can I find? I can find MR, or molar mass, right? So MR of Px is basically 124 over 1, which is 124. Because remember, moles equals to mass over molar mass, or MR. Therefore, your molar MR is equals to mass over moles. Okay. So I do have a summary of all the formulas for your O-level mole concept. Okay, I'll provide the link in the description below. So just now we were looking at this, moles equals to mass over molar mass. There are also many other formulas here. Okay, as well as stoichiometry rules. So if you want a summary of all the formulas tested in mole concept and stoichiometry, you can refer to this post here. I'll provide the link in the description below. So now we know from our calculations that the MR of phosphorus is 124. So now let's take a look at our periodic table. So P, okay, 1P has an AR of 31. So how many P do I need so that the MR is 124? Okay, so we know that 1P has an AR of 31. So the MR of Px is actually x times 31, right? 31x. And we know that is equals to 124. So to find x, we will take 124 divided by 31, which gives us 4. So therefore, we know that the formula of phosphorus is P4. So the answer for this is C. Right? Now let's move on to question 9. So the mass of 1 mole of chlorine formed by metal Y is 74.5 grams. What's the formula of the chloride? So you have 1 mole of chloride formed by metal Y is 74.5 grams. So we know that there is 1 mole. We know mass. So this is mass. This is mole. So what can we find? We can find MR, right? Or molar mass, right? So MR or molar mass is equals to mass over mole, which is equals to 74.5 over 1, which is 74.1. Okay? So now, based on this, we know that so we know this already. So what other information do we have? Okay, so we know that we do not know what is the formula of the chloride, right? Okay, but we do know what is the AR of chlorine. So 1 Cl will have a AR of 35.5, and 2 Cl will have an AR of 71. Okay, so we know that 1 Cl will be 35.5. Okay, and the charge of Cl is minus. So the charge of Cl is minus, right? So if you to look at it, right, is it possible to have Y3Cl or Y2Cl? No. Why? Why is it so? So let's take a look. If one Cl has a charge of -1, in order to form Y2, okay, in order for the matter, because this is not a non-matter where you can form your ions and so on. So in order for each Y, right, so in order to have Y2, that means each Y must have a charge of plus 0.5. So they have Y2Cl. Is it possible? No, right? We know it's not possible, right? Because from the metals here, the charge is +1, +2, +3. You don't have +½ for a charge for metals, right? You cannot lose half an electron. So from here, we know that Y2Cl, Y3Cl is not possible. Okay, because if you have Y2Cl, that means each Y must have a charge of +½ If you have Y3Cl, each Y must have a charge of +1/3, which is not possible. So we'll eliminate A and B. Okay, so we are left with YCl and YCl2. Okay, and we know that the total MR is 74.1. Okay, so now let's take a look at your Cl. So we know that Cl has an AR of 35.5. Okay, and if both of them, the MR is 74.1, that means the AR of Y is basically 74.1 minus 35.5, right? So in other words, right, the Y must have a AR of 38.6. Okay, so that both of them add up to be 35.5. Now, if I have Y, okay, another thing I need to note for this is this Y must have a charge of +1 so that it forms YCl. So let's take a look at the periodic table again. Okay. So I have 38.6, is it? 38.6. Okay, 38.6. Okay, 38.6. Okay, and I need it to have a charge of +1. So very likely, maybe possible 38.6. Maybe it's this one, an isotope of potassium, so that I get 38.6, which is very close to 39. Okay, and potassium also have a charge of +1, so very likely possible, right? So this YCl is actually KCl. Okay. So this is possible, C, because it is KCl, right? Because K has an AR that is 39, which is very close to 38.6, because for your data booklet, for your periodic table is basically rounded off, right? So 38.6 round off is 39, so likely is K. Next, before we conclude that C is the answer, let's check D. So for D, I have 2Cl, so it's YCl2. So 2Cl will already use up a mass of 71. So in order to have 74.1, that means this Y must have AR of 3.1. Also, to form YCl2, this Y must have a charge of +2. So let's look for 3.7, an AR of 3.7, and in group 2. We don't. 3.7, an AR of 3.7 is very close to 4, which is helium. Right? Round off is 4, it's helium. Helium is not a matter. The next closest is 7, which is a bit far off, and it is group 1, not group 2. So based on this, we can conclude that D is unlikely to be the answer, and the answer for question 9 is C. Alright? Okay, let's move on to question 10. The energy level diagram for the reaction between sodium hydroxide and hydrochloric acid is shown. Okay, so basically this is an acid-base reaction. The ionic equations for all acid-base equations is basically H plus OH minus, you form H2O. Okay, so we know that this reaction is exothermic because the energy level of the reactants is higher than the energy level of the product. Okay, and the delta H is minus 54 kilojoules per mole. Now you're asked, what is the energy given out when 100 cm3 of 1 mole per dm3 hydrochloric acid reacts with 100 cm3 of 1 mole per dm3 sodium hydroxide? So you are given volume and concentration. So if you are given volume and concentration, in order to find the number of moles, you will take moles equals to volume in dm cube multiplied by concentration in moles per dm cube. So 100 cm cube is basically 0.1 dm cube because I take 100 divided by 1000. So basically I have 0.1 moles, okay, of hydrochloric acid. Okay, similarly I also have 0.1 moles of sodium hydroxide. So if I have 1 mole of H plus reacts with 1 mole of OH minus, I'll get 1 mole of H2O, and the energy that is evolved is negative 54 kilojoules per mole. So now if I have 0.1 moles of H plus reacting with 0.1 mole of OH minus, okay, then I will have 0.1 mole of H2O that is being formed, and the energy that is liberated will be going to be 0.1 times negative 54. Okay, so the amount of energy that is going to be liberated is going to be negative 5.4, okay, kilojoules. So because they already say what energy is given out, so there's already a negative sign, so we just need to write 5.4. So the energy that is liberated is 5.4 kilojoules. All right. Moving on to question 11, the isotopic composition of an element is indicated as below. What is the relative atomic mass of the element? So to find the relative atomic mass, we need to find the average. So you can think of it as like there is one relative abundance is 1, relative abundance is 4. So let's assume that there's one molecule or one atom here. There's one atom here. So one atom has a mass of 10 and 4 of them has a mass number of 11. So what's the average? So it's basically 1 times 10 plus 4 times 11 divided by 5. Okay, so this will give us an answer of 10.8, okay, which is C. Moving on to 12, a solid nitrate fertilizer reacts with an alkali to produce a gas which turns damp red litmus paper blue. So turns damp red litmus paper blue, what gas is this? It is your ammonia gas. So in my website here, I share what you will observe or how do you test for different type of gas and what is being observed. So once you see turn damp red litmus paper blue, straight away think of ammonia gas is being produced. So now that we know that ammonia gas is being produced, let's take a look at the question again. So we know that this solid nitrate fertilizers react with alkali to produce a gas that turns damp red litmus paper blue, and this gas is ammonia. So you put alkali and heat it and you produce ammonia. Okay, you did not add any aluminum foil or the Vardas alloy. So in other words, right, it is the ammonium that produced the ammonia gas. Okay, so take note of this. Okay, so if you are to look at your qualitative analysis table for testing of anions, for nitrate, in order for ammonia gas to be produced, okay, when sodium hydroxide is added and the solution is warm, you need to also add aluminum foil or the Vada's alloy. So because we did not add any aluminum foil here, we know that the ammonia gas that is produced doesn't come from nitrate. Instead, it comes from ammonium, because when you add sodium hydroxide to ammonium, okay, and you warm it, ammonia gas will be produced. You do not need to put any aluminum foil and so on. Alright, so based on this, we know that the ion that results in ammonia gas that is being produced is ammonium. We are also told that there is nitrate, right? Nitrate present in the fertilizer. So therefore, this fertilizer contains ammonium and nitrate, and therefore it is ammonium nitrate. So NH4NO3. And they're asking for the empirical formula. So there are 2 N here, 4 H here, and 3 O here. So the formula is N2H4O3, which is D. Okay, so the answer for this question here is D. No, it's not. Is it? Yeah, it is D. Okay. Next, let's move on to the next question. Next, let's take a look at this question here. Question 13. The apparatus shown below was set up to copper plate and metal spoon. So one look at it, we know that this is a plating experiment. So if you want to electroplate something, okay, AOCR, the one that you want to plate will be placed here to be plated. Will be at the cathode. The metal itself that you want to use for plating, that means it will dissolve in the solution, is at the anode. So anode will always be the one that dissolves, okay? So if you want to use this copper, it should be at the anode. And anode is going to be positively charged and cathode is negatively charged. So the anode is going to be connected to the positive terminal of the battery. But here, we are going to use this foil, right? So this foil, I want to plate it on the spoon. So, but now the foil is connected to the negative terminal. So it is the cathode. And this spoon is the anode. So the spoon will dissolve, right? If it is a reactive metal, if it's not inert. Correct? So, and your copper foil will not coat on the spoon. The spoon might coat on the copper. Okay, because you put anything on the anode and it is able to react, that means it is not an inert electrolyte like platinum, graphite, then say goodbye to it. That means it will dissolve, okay? It will dissolve, go to the solution. So the spoon, if it is not made of inert metals, then it will slowly dissolve. So that's why it doesn't work. Okay, dilute sulfuric acid should be used as the electrolyte. No, I want to coat with copper, right? I put copper foil, copper 2 sulfate because I want to coat with copper. So therefore, copper 2 sulfate is correct. Okay, the problem is you have put the spoon and the copper foil at the wrong place. Next, molten copper 2 sulfate should be used as the electrolyte. No need, because copper is below hydrogen in the reactivity series. So at the cathode, copper will be preferentially discharged, okay, instead of hydrogen. So therefore, yes, you can coat copper 2 sulfate, okay, using aqueous copper. Your electrolyte can be aqueous copper 2 sulfate. You don't need molten. The battery should be replaced with a voltmeter. Also no, because we need energy. This is not a cell. Okay, this is not an electrochemical cell. We want to use energy to transfer the copper from the anode to the cathode. Okay, if you have no battery, there's no energy source, then this will become a battery. So it needs to have a difference in potential. That means they need to be made of different metals in order for it to work as a voltmeter. Maybe it works because they are different metals. Maybe the spoon and the copper foil has different metals. But no, we want to coat the metal spoon with copper. Okay, we do not want this to be used as a battery. Okay. The next The spoon should be the negative electrode. Yes, the spoon should be the cathode, which is the negative electrode. So the answer is D. So for 13, the answer is D. Next, let's go on to question 14. In the commercial electrolysis of concentrated sodium chloride, the products are chlorine, hydrogen, and sodium hydroxide. What is the maximum yield of chlorine and hydrogen when 58.5 kg of concentrated sodium chloride is hydrolyzed? So you can do this in many ways. So they already tell us that we start off with NaCl aqueous. Okay, and let's just put some water here. Okay, so we know that the products is NaOH and chlorine and hydrogen. You know why I put the H2O? Because I know that the hydrogen comes from the H2O, right? Because NaCl doesn't have any H. Okay, so we know that you have an NaCl react with H2O. Okay, NaCl react with H2O. What do we get? We get NaOH plus Cl2 plus H2. Okay, then next thing, what do we need to do? We need to balance the equation, right? Okay, so I know that I need 2 Cl2 here, so definitely there's 2 here. There's hydrogen, so 2. Okay, because once I have 2 NaCl, I need 2 NaOH to balance the Na. So if you check this, this is our balance, 2 Na on both sides, 2 Cls on both sides, 4 H on both sides, 2 plus 2 is 4, 2 O's on both sides. So this is the balance equation. So I know as 58.5 kg of concentrated sodium chloride. Okay, so let's assume all of it is sodium chloride, 58.5 kg. So let's assume, because they say maximum, right? Okay, so if it's maximum, okay, so let's say that I have 58.5 kg of sodium chloride. So 58.5 is 58500 grams. So the number of moles of NaCl is basically mass in grams divided by the molar mass, which is 23 plus 35.5. Molar mass of Na is 23, Cl is 35.5. Just check the periodic table. Okay, so put this in your calculator. We will get 1000. Okay, so that means there is 1000 moles of NaCl if 58.5 kg are all sodium chloride. Okay, then next, from this equation here, we know that 2 moles of NaCl will give 1 mole of Cl2. So the number of moles of Cl2 is equals to 1000 divided by 2, which is 500. Okay, so the mass of Cl2 is basically moles times the molar mass, which is 35.5 times 2. Okay, so it is 35500 grams or 35.5 kg. Okay, next let's look at the yield of hydrogen. So we know that there's 1000 moles of NaCl, so 2 moles of NaCl give 1 mole of H2. So 1000 moles of NaCl will give 1000 divided by 2, which is also 500 moles of H2. So moles of H2 is equals to 1000 divided by 2, which is 500. The mass of H2 is basically number of moles times the MR, which is 2 times 1. So I know that there's 1000 grams of H2 or 1 kg. So I know that the maximum yield of Cl2 is 35.5 kg and the maximum yield of hydrogen is 1 kg. So the answer for question 14 is A. Alright. Okay, now let's move on to the next question. Question 15. The diagram shows the electrolysis of molten lead to bromide using inner electrodes connected to external battery. Okay, so we know that we have electrolysis of molten bromide, lead to bromide. So because it's molten, that means there's no aqueous, there's no water. The only ions present is Pb2 plus and Br minus. So at the cathode, okay, the cations are discharged. Okay, so we have Pb2 plus forms Pb. Okay, at the anode, okay, sorry, Anode is positively charged, cathode is negatively charged. Okay, anode is the positive electrode. So, and the anions will be attracted to the positive electrode. So your Br minus will form Br2 plus 2E minus. So we know that bromine and lead will be formed. Okay. New compounds are formed. No, we form not compounds but elements. Lead element and bromine element. Lead only contains lead, so this is an element. Br2 only contains Br, so it's an element. So no compounds are formed. We only form elements. Reddish brown gas is formed at the cathode. No, the reddish brown gas, which is bromine, is okay. It could be a gas because of the high temperature. Reddish brown gas is formed at the anode, so B is out. Silvery molten matter is formed at the positive terminal. No, this is the silvery molten matter. Lead is the silvery molten matter, is formed at the cathode, and the cathode is negatively charged. Wrong. The volume of electrolyte decreases over time. Yes, because bromine gas is formed and it will be discharged, right? It will just vaporize out. So the amount of substances left will decrease, so the volume will decrease. So D is the answer. Moving on to question 16, nitric oxide NO and bromine vapor react together in an equilibrium reaction. The forward reaction has an activation energy of 5.4 kilojoules per mole. What is the activation energy of the backward reaction? So let's just draw out the energy profile diagram. So this is energy. Okay, for simplicity, I'll write this as the reactants, this as the product. Okay, don't do that for exam, but this is MCQ, so I can do that. This R, this is P. Okay, and I know that the product is at a lower energy level than the reactants because why? Because this is negative, so products is at a lower energy level. So here's minus 23. Okay, I don't want to write the unit, so I'll write kJ per mole here. Okay. Next, I also know that the activation energy here is 5.4 kilojoules per mole. So now, what's the activation energy of the backward reaction? To find the activation energy is basically from where you start, okay, to the highest point, right? So the activation energy of the forward reaction is basically 5.4 because it's from the reactant, because we start with this, which is your NO and your Br. Okay, we start off with NO and Br and we go to the highest point, so it's 5.4. To find the activation energy of the backward reaction is basically starting with NOBr, which is here, and go to the highest point. So it will be 23 plus 5.4, which is 28.4 kilojoules per mole. Okay, so activation energy is always positive because you need to gain the energy in order to, you need to overcome the energy in order for the reaction to take place. So activation energy is definitely plus, so anything that is minus is out. So the answer is D for question 16. Moving on to question 17, the combustion of methane is exothermic. The equation is given below. What can be deduced from the reaction? So you know that it's exothermic, right? So basically they are asking you, oh, if you know it's exothermic, what can you conclude? So fewer bonds are made. No, it has nothing to do with how many bonds that are being formed. Okay. So let's look at this. Fewer bonds are broken than made. Okay, no, it has nothing to do. It is the bonds formed are stronger than the bonds broken. Less energy is involved in bond breaking than is involved in making bonds. Yes, this is true. Okay, that is why it is exothermic, right? Because less energy is involved in breaking the bonds, more energy is given out when the bonds are formed. Next, more bonds are broken than made. Nothing to do with more or less. It is the energy involved. You have 10 bonds that are being broken, but they are so weak. Okay, even if you form one super strong bond, it will still be exothermic. So it has nothing to do with how many bonds are broken. It is the energy involved in the bond breaking and bond forming that makes something exothermic or endothermic. more energy is involved in breaking bonds than is involved in making bonds? No. So less energy. If more energy is involved in breaking the bond, then it will be endothermic. So this is out. So the answer for 17 is B. Next, let's look at question 18. A student measured the temperature change when 4 grams of potassium chloride granules was dissolved in excess water. Her calculated energy change from the reaction is positive 720 joules. So this is an endothermic reaction. The temperature decreases. Okay, which statement is correct? The energy change when 1 mole of potassium chloride dissolved in water is 13.4 kilojoules. So this is 4 grams, right? So we first need to find the number of moles first. So to find moles, you will take mass, which is 4, divide by AR of potassium chloride. So potassium chloride is KCl. So 1K has an AR of 39. 1Cl has a AR of 35.5. So it will be 39 plus 35.5. Okay, so type this into your calculator. You will get 0.0537 moles. Okay, so now you have this number of moles. Okay, you can go on to find so you know that 4 grams will give 0.0537 moles, or you know that 0.0537 moles, okay, will give positive 720 joules. So how about 1 mole? 1 mole will give 720 divided by 0.0537 joules, okay, which is equals to around 13,410 joules, which is around 13.4 kilojoules. So A is correct, right? So 18 is correct. The energy change will be greater when powdered potassium chloride is used. No, when you use powdered, okay, or granules, it only affects the rate of reaction. It doesn't affect the heat change. The energy level of the product is lower than the reactant. This is an endothermic reaction. For endothermic reaction, the product is at a higher energy level than the reactants. The reactants is the product. So the reactants are at a lower energy level than the product, so that your delta H is positive. So this is incorrect. The sign of the temperature change is positive. The sign of the temperature change is negative because the temperature decreases. Okay, so the answer for 18 is A. Question 19. When magnesium reacts with dilute sulfuric acid, a gas is released. Okay, so magnesium reacts with dilute sulfuric acid, the gas that is released is hydrogen. Metal plus acid, you will give salt plus hydrogen, provided that the metal is above hydrogen in the reactivity series. Magnesium is way above hydrogen in the reactivity series. It will react and give hydrogen gas. So in a series of experiments, 0.1 grams strips of magnesium are reacted separately with different concentrations of dilute sulfuric acid. In each experiment, the acid is in excess. The reaction time taken for the magnesium to react completely is recorded for each experiment and shown in the diagram in the graph below. So you notice that as the concentration increase, the time taken actually decrease until beyond a certain point it just plateaus. Okay, doesn't make much of a difference. Okay, so next, which statement is correct? The approximate time when 1.5 mole per dm³ of sulfuric acid used is 10 seconds. So if we look at here, we know that once it goes beyond maybe 0.95 mole per dm³, the time that is taken is more or less constant, right? So at 1.5 mole per dm³, which is far away, we know that very likely it still remains the same, which is this value here. And we know that yes is 10 seconds. So here is 10, right? If you look at the vertical axis, it will go to 10 here. So this is correct. the rate of reaction decreases with increasing concentration. No, the rate of reaction increases with increasing concentration. That is why the time taken decreases. The same volume of hydrogen is produced in each experiment. So let's take a look at this. So what is in excess? So the acid is in excess. Because the acid is in excess, what determines the volume of hydrogen produced, or what determines the amount of product? Well, it is the other reactant. The limiting reagent determines the amount of product that is being formed. And the limiting reagent is magnesium, and throughout the experiment, we always use 0.1 grams of magnesium. We did not change. So therefore, the volume of the product, which is hydrogen, form will always remain the same. So therefore, for question 19, statement 1 and 3 are correct. So the answer is B. Moving on to question 20, bromine is extracted from seawater. In the final stages of the process, two redox reaction takes place. So they give us these two reactions. So which row is correct? So we are asked to determine basically the oxidizing agent and the reducing agent. So the oxidizing agent is the one that is being reduced, and the reducing agent is the one that is being oxidized. All right. Okay, so for the oxidizing agent, so let's take a look at this. So we know that bromine, so I'll use oxidation state because it's the easiest. Okay, it works all the time. For hydrogen and oxygen, you need to have hydrogen and oxygen in order for there to be oxidation and reduction. Okay, if not, you have to use oxidation state or electrons. It's easier to look at, I prefer looking at oxidation state. It's easier, it's less confusing. So for bromine, it is an element, so its oxidation state is 0. For Br here, the oxidation state is -1 because in HBr, the oxidation state of Br is -1. Okay, next we have SO2. So O always has an oxidation state of -2 unless you have oxygen, which is an element, so it will be 0. Or if you have hydrogen peroxide H2O2, then O will have an oxidation state of -1. But here you have SO2, so O has an oxidation state of -2. You have 2 oxygens, so 2 oxygens, total -4. So S must have an oxidation state of +4, so that everything adds up to be 0. I will look at water because I can look at water here. So H is +1, O is -2. Okay, H is +1, O is -2 on both sides. So don't need. So definitely not water. Water is not going to be oxidized or reduced. So B and D are out. Okay, so now let's take a look at this. So each H has an oxidation state of +1, so 2 of them will be +2. Each O has an oxidation state of -2, so each of them will have an oxidation state of -2, so 4 of them is -8. So sulfur must have an oxidation state of +6, so that the sum of the oxidation state adds up to be equals to 0. So sulfur is being oxidized because its oxidation state increases from +4 in SO2 to +6 in H2SO4. So therefore SO2 is being oxidized. It is the reducing agent. Okay, and Br is being reduced. So oxidation state of Br decreases from 0 in Br2 to -1 in HBr. So it's an oxidizing agent. So the answer is A, right? So let's check why for the step 2, Cl2 is the oxidizing agent and HBr is the reducing agent. So Cl2, 0, right? Because it's element, then Cl here is -1, so it is being reduced. Cl is being reduced, so it is acting as an oxidizing agent. So for HBr, the oxidation state of Br in HBr is -1. The oxidation state of Br in Br2 is 0. From -1 to 0, there's an increase in oxidation state. HBr is being oxidized, so it acts as a reducing agent. So therefore, A is the answer. Next, let's move on to question 21. So in question 21, you talk about volcanic areas. The air pollution due to hydrogen sulfide causes white lead paints to blacken because of the following reaction. Okay, so which statement about the reaction is correct? So basically, they ask about different things: oxidation, reduction, and also acid. Okay, so what is an acid? What do you know about an acid? An acid produces H plus in water, right? So later we'll take a look at whether 2 is correct. So let's first start off with 1. Carbon is reduced. So if you're to check the oxidation state of carbon in carbonate, So here, or you can look at this is lead 2. Okay, why I know it's lead 2? Because carbonate has a charge of -2, and Pb must have a charge of +2, so that you form a formula PbCO2 3 minus PbCO3. So now I know that lead is +2. Each oxygen has an oxidation state of -2. There are 3 of them, so here is -6. So 2 minus 6 is -4. That means carbon must have an oxidation state of +4 in order for the sum of the oxidation state to be equals to 0. Okay, so now that you are done with that, okay, let's check the other one. Okay, so now let's take a look at the other side here. So your CO2 here, so each O has a oxidation state of -2. There are 2 of them, so it's -4. So this C must have an oxidation state of +4. So in other words, we know that nothing happens to the C, right? Its oxidation state remains as +4. So it's neither oxidized or reduced. So this is out. Next, hydrogen sulfide acts as an acid. So H2S from H2O. It's not an acid, right? There's no acid reaction, or is there? Oh, there is. Okay, if you look at this, this is a carbonate, right? So if carbonate react with acid, it will give carbon dioxide, water, and salt. So this S just is like the anion of the salt. Okay, then you have water and carbonate. So yes, this is correct. Hydrogen sulfate acts as an acid. So this is an acid-carbonate reaction. Next, let's look at hydrogen sulfide. Is it being oxidized? Definitely not, because to the H, each H has a oxidation state of +1. 2 of them is +2, so S is -2. So this is lead 2, right? So this charge is +2. So here will also be -2. So the oxidation state of S remains the same. So it's not true because it's neither oxidized or reduced. So basically, it is 2 that is correct. H2S acts as an acid. So in other words, the answer for question 21 is B. Or you can just remember that, right, for for acid carbonate reactions, right, it is not a redox reaction. So therefore, you will not have so you do not need to have any redox. So once you see an acid carbonate reaction, right, any reduction, any oxidation should be out. You can straight away go to this. All right. Next, let's look at this. The pH of 4 different solutions is measured using a pH meter. All solutions measured have the same concentration. The data is recorded below. Which row shows the correct order of pH measured? So you have W, X, Y, and Z. Okay, so which one do you think all solutions have the same concentration? So they all have the same concentration. Okay, so straight away we know that sodium hydroxide has the highest pH. Reason is because it's an alkali. Then alkali will have a pH that is generally greater than 7. So in other words, right, the one with the highest pH is Z. So we are left with A and B. Next, we know that out of these 3 acids, ethanoic acid is the weak acid, while sulfuric acid and hydrochloric acid are strong acid. So we know that the next answer will be Y. So before doing that, we know that A is the answer. But before we I go on to the next question, I want to explain why sulfuric acid has a lower pH than HCl, okay, hydrochloric acid, when they are of the same concentration. Let's look at H2SO4. Let's just assume that it's 1 mole per dm cube. Then I have HCl, which is also 1 mole per dm cube. So in H2SO4, there are 2 moles of H plus per mole of H2SO4. So in other words, the concentration of H plus in H2SO4 is 2 moles per dm cube. Okay, if you have a 1 mole per dm cube H2SO4. But for HCl, for a 1 mole per dm cube H2SO4, for a 1 mole per dm cube HCl, you only have a 1 mole per dm cube H plus. Right? So therefore, the concentration of H plus in H2SO4 is twice the concentration of H plus in HCl. So therefore, H2SO4 is more acidic and therefore it has a lower pH. Okay, so the answer is A. Alright, next let's move on to question 23. Salt P can be prepared by reacting together a dilute acid or an emitter, or an acid and an insoluble carbonate. So let's look at this. A pure sample of salt P is then obtained by filtration followed by crystallization. Which salt is P? So there are some things that we know once by looking at this. So we know that straight away it can be formed by reacting a dilute acid and a metal. So we know that the metal is above hydrogen in the reactivity series. So the first stop, we will eliminate any metal that is below hydrogen in the reactivity series. So what is out? Copper 2 sulfate is out. Lead is slightly above. So let's just keep it there first. Okay. Next, an acid and an insoluble carbonate. So in other words, next we know that this metal must form an insoluble carbonate. So what carbonates are insoluble? So basically, if you look here, right, as long as it's not a group 1 carbonate or an ammonium carbonate, right, it will be insoluble. So in other words, right, we eliminate the sodium carbonate option. Okay, reason, okay, is because sodium carbonate is soluble, and they already tell us that it is an insoluble carbonate. So sodium carbonate out. Okay, next, a pure sample of salt P is then obtained by filtration followed by crystallization. So we know that this salt P, okay, whether you react the metal with the acid or the carbonate with the acid, okay, it must be a soluble salt. And in fact, in order for it to be you to use this method, it must be a soluble salt, right? Okay, so now let's take a look at these two options that we are left. So if I've lead 2 sulfate, okay, then the acid must be sulfuric acid. Okay, then in the first one you have sulfuric acid plus lead, and the second one you have sulfuric acid plus lead 2 carbonate. Okay, but what is the problem with lead 2 sulfate? Okay, so we need to form a soluble salt, right? Because a pure sample of salt is then obtained by filtration followed by crystallization. So in other words, this P is in the salt solution, so it must be soluble. So what do we know about lead sulfate? Lead sulfate is insoluble. Okay, so if you take a look at this, sulfates are insoluble. Okay, lead 2 sulfates are insoluble in water. So therefore, if it is lead 2 sulfate, then it will not be a solution. So we will not have a pure sample of P in a solution that can be obtained by filtration followed by crystallization. You don't need crystallization if it is a solid, right? Okay, you'll just get it by filtration. But we know that there are more problems to it, okay, because the insoluble lead 2 sulfate will precipitate on top of the carbonate or the metal, okay, and then the reaction will stop before all the metal or the carbonate has reacted. So it's a bad idea. So in other words, we know B is out. Okay, so C is the answer. So why C is the answer? So if you look at magnesium chloride, we know that if you want to have chloride being the salt form, the acid that you use is hydrochloric acid. Okay, so if you have hydrochloric acid, then you can have magnesium metal. So you form magnesium chloride, which is soluble, because all chlorides are soluble except for some exception, and magnesium hydroxide doesn't fall under the exceptions. Okay, if you look at this table here. All right, okay, so magnesium chloride is soluble because it's not lead 2 chloride, it's not silver chloride. All right, okay, coming back to here. Okay, so now if you have to look at this, then we know that the solution of P is magnesium chloride, which is a soluble solution, and we know that magnesium metal can react with hydrochloric acid because magnesium is above hydrogen in the reactivity series. It will react. This metal will react with acid to give hydrogen. We also know that magnesium carbonate is insoluble, so it also satisfies this second statement here. So therefore, the answer is C. Now I want to go through question 24. So in question 24, you're given the flow diagram below shows how ammonia is produced industrially and subsequently processed to become ammonium phosphate, commonly used as a fertilizer. So you have nitrogen plus a gas Q with a metal R, you form ammonia. So ammonia is formed from the Haber process from nitrogen and hydrogen. So the gas Q is hydrogen. And in the presence of the catalyst, which is iron, okay, so the iron catalyst. Okay, then now you have ammonia. Ammonia from ammonium phosphate. Ammonia is a base. Okay, so to form the salt here, we basically add phosphoric acid. Okay, so ammonia plus phosphoric acid will give you ammonium phosphate. So now let's take a look at this. Which statement is not correct? Gas Q is a compound that can be obtained by cracking of crude oil. So hydrogen can be obtained by the cracking of crude oil. But before you say that it's correct, there's this word here that's out to trick you. H2 is an element, not a compound. So therefore, A is wrong. Okay, so the answer is A. But before we go on, let's take a look at the rest. Metal R speeds up the rate of the reaction. So iron acts as a catalyst, so it speeds up the rate of the reaction. This is correct. Next, substance S reacts with ammonia in an acid-base reaction. So substance S is phosphoric acid. It will react with ammonia in an acid-base reaction. This is correct. The reaction between nitrogen and gas Q is reversible. The Haber process is a reversible reaction. Okay, so this is also correct. So the answer for 24 is A. Now let's move on to question 25. Halogens are a group of diatomic elements in group 7. Which property shows decreasing trend down the group? So they are asking for the decreasing trend down the group. So ability to act as oxidizing agents. So if you look at this, F forms F minus very readily. Okay, in other words, it gets reduced very readily. And this ability to get reduced decreases down the group. So in other words, right, because it gets reduced very readily higher up in the group, in other words, it means that the oxidizing power decreases down the group, or in other words, the reducing power increases down the group. So that is why, right, the higher halogens can displace the lower halogens from their aqueous salt solution. Okay, so let's take a look at the options for this. Here, right? So their ability to act as oxidizing agent decreases down the group. A is correct. Boiling point increases down the group. Okay, so this is not correct. Color intensity, it gets darker in color as you go down the group. So color intensity increases, not decreases. So C is wrong. Density also increases going down the group, because as you go from fluorine all the way to astatine, this is a solid that has a much higher density compared to fluorine, which is up in the group 7, which is a gas. So the answer for 25 is A. Let's take a look at question 26. So in question 26, elements T, U, V, and W are 4 successive elements in periodic table. Element T has an atomic number of 12. So once we know that element T has an atomic number of 12, we can go straight to the periodic table. And from here, we can determine what is it. So atomic number is the number on top. Okay, if you look at this key here. So the one that has an atomic number of 12 is magnesium. So we know that this is magnesium and this is T. So U will be aluminium. Silicon will be V, and phosphorus will be W. Okay, so this is T, U, V, and W. So let's write it out. Okay, so we know that T is magnesium, U is aluminium, V is phosphorus, and W is sulfur. Okay, so now let's take a look. Melting point of V is higher than that of W. This is incorrect. Sorry, V and W. So this is possible. Okay, sorry, not P. This is Si and P. Nope. So let me check. MgAlSi and P. And P, right? Phosphorus. Let's see. So it's Mg followed by AlSi then P. Okay, so let's go back to page 12. Okay, so now melting point of V is higher than that of W. This is definitely correct because silicon is a macromolecule. It has a higher melting point compared to phosphorus, which is a simple molecule. Okay, next, W has a higher melting point than U. W is phosphorus, U is aluminium. Metals generally have a higher melting point, okay, because the van der Waals force or the intermolecular forces in simple covalent molecules are weak compared to the electrostatic force of attraction between the metal cation and the electron. So this is wrong already. Next, W has a higher melting point than T. This is wrong because molecules will have a lower melting point than matter. Magnesium is a metal. Next, V and W. V has a higher melting point than W. This is correct. We talked about it already. Now let's take a look at A. Electrical conductivity of W is greater than that of U. This is definitely wrong. U is aluminium, is a metal. It has a higher electrical conductivity. In fact, it can conduct, is a good conductor of electricity. And phosphorus is a poor conductor of electricity. So this is wrong because W, it has a lower electrical conductivity compared to aluminium. T has a greater electrical conductivity than W. This is correct. Okay, so we know that the answer is D. It's because magnesium is a good conductor of electricity. It is a metal. Phosphorus is a non-metal. It's a covalent molecule. It's a poor conductor of electricity. Next, forms basic oxide. So we know that only magnesium, which is T, forms basic oxide. Aluminium forms amphoteric oxide. Silicon and phosphorus being non-metals, they form acidic oxide. So the answer for 26 is D. Let's move on to question 27. So in question 27, you're told that scrap metals often consist of a mixture of aluminum, iron, chromium, copper. In the recycling of metals, only the first two steps use physical methods, while subsequent steps use chemical methods. The following describe the first two steps used. So in the first step, you use a large magnet. So to use the large magnet, you separate out iron and steel. So the first step, you take out iron and steel. So only B and D has iron. So we will eliminate A and C. Step 2, separate the least dense metal by using a modified water bath with a suitably adjusted density. So we have a mixture of aluminium, iron, chromium, and copper. So you have already taken out iron, so you are left with aluminium, chromium, and copper. So we want to take out, so this step we'll take out the least dense metal, right? So let's take a look at aluminium, chromium, and copper in the periodic table. So here is chromium, here is copper, and here it's aluminium. So we know that aluminium has a low density, that's why it's used for aircraft body. Copper and chromium, they are in the transition, they are transition elements because they are found here between group 2 and group 3. So transition elements, they all have high density. So we know that aluminium will be separated because it has the lowest density compared to chromium and copper. So we know that in this step, second step, we will get out aluminium. So the answer is B. Okay. Next, let's look at question 28. The list shows the position of metal X in the reactivity series of metals. So we have sodium, aluminium, iron, X, Cu, and Ag. Okay, so we know that sodium, so out of these 6 metals, sodium is the most reactive. Ag, silver is the least reactive. Which method could be used to extract metal X? Electrolysis of molten metal oxide, definitely, because if you have molten X, okay, so there is only X, the ions of X, okay, that is positively charged because you have molten metal X. Okay, the other ion is O2 minus, which is negatively charged. So the positively charged metal ion of X will go to the cathode and be discharged. So you'll be able to extract metal X. So 1 is true. Heating the metal oxide with carbon. So we know that as you go down the reactivity series, or as reactivity decreases, it gets easier to extract the metal. Okay. by heating it with reducing agents like carbon. So we know that when we reach iron, okay, remember the blast furnace, you can obtain iron by heating its oxide with carbon or carbon monoxide. So if you can already extract iron by heating the metal oxide with carbon, then we can also obtain X by heating it with the reducing agent like carbon. So yes, we will be able to obtain X, okay, by heating its oxide with carbon. 3. Heating the metal oxide with copper. So we know that X is more reactive than copper. The more reactive the metal, the more it prefers to stay as an ionic compound. So if you heat metal oxide with copper, this X prefers to stay as an oxide. X prefers to stay as an oxide more than copper. So therefore, you will not be able to obtain X by heating metal oxide with copper. There will not be any reaction. You will not form copper oxide because copper is less reactive. Less reactive means you prefer to stay as a metal. Okay? So the answer is 1 and 2, and so therefore the answer is B. So if you'd like to know more about what happens, so how you can extract metals, okay, or what are the reactions of metals, okay, I will provide this link in the description below. So basically, right, for these metals here, potassium all the way up to aluminium, you can only extract them by electrolysis of their molten compound. But from zinc onwards, right, you'll be able to extract them, okay, by heating with reducing agent. Then for very unreactive metals, they just exist by themselves. So now coming back to our question, let's go on to the next question. So question 29, the following is an experimental setup to determine the relative thermal stability of metal carbonates. Which row shows the correct observation? So we know that the more reactive the metal, the more stable their carbonate. So group 1 carbonates, they are very stable to heat. They will not decompose on heating. So other carbonates, they will decompose on heating to give carbon dioxide. So when the carbon dioxide will be liberated, it reacts with lime water to give a white PPT. Okay, so we know that group 1 carbonates, they will cause lime water to remain colorless because no CO2 is produced. So K2CO3, okay, when you heat K2CO3, the lime water remains colorless. But for magnesium carbonate and copper 2 carbonate, the lime water will you have a white PPT. So we know straight away that B and C are out. We only need to check A and D. So now we are left with magnesium and copper. So we know that magnesium is above copper in the reactivity series. So magnesium is more reactive than copper. So in other words, copper 2 carbonate is less stable. So when something is less stable to heat, it means that it will decompose more readily and it will take less time, okay, to decompose. So if it takes less time for copper 2 carbonate to decompose, it means that you will produce carbon dioxide more readily. So you use less time to give out carbon dioxide. So the amount of time taken for copper 2 carbonate to give out carbon dioxide is lesser than that of magnesium carbonate. So the answer is A. Okay, moving on to question 30. Iron is extracted from hematite in the blast furnace. Which reaction that takes place in the blast furnace is not a redox reaction? So you also learn some reactions that are not redox, right? Acid-base reactions are not redox. Precipitation reactions are not redox. So even without doing this, we know the answer is D. Okay, because SiO2 is an acidic oxide, silicon dioxide is an acidic oxide, calcium oxide is a basic oxide. Acidic oxide plus basic oxide is an acid-base reaction to form a salt. So acid-base reactions are not redox. There's no change in oxidation state of everything. Okay, but if you look at A, okay, for this question, it's easier to look at oxidation and reduction in terms of oxygen because of A, B, and C involves oxygen. So you look at carbon, okay, no oxygen becomes CO2, that means it gains oxygen. So C is being oxidized. Okay, oxygen, it goes from O2. So O2, the oxidation state of O is actually 0. Then in CO2, the oxidation state of O is -2. So this oxygen is being reduced. Okay, so this is a redox reaction because you have both oxidation and reduction. For B, carbon dioxide, because carbon monoxide, it loses oxygen, so it is reduction. Carbon gains oxygen to become carbon monoxide, so carbon is being oxidized, so this is a redox reaction because there's both oxidation and reduction. For C, this is essentially a reduction reaction, okay, because the iron 3 oxide undergoes reduction to form iron so that you can extract it. Okay, and this is done by heating with a reducing agent, which is carbon monoxide. So in this case, your iron 2 oxide, it loses oxygen, okay, so it's being reduced. Carbon monoxide, it gains oxygen to form carbon dioxide. So this is C is also a redox reaction. So A, B, and C are redox reaction, except for D, which is not a redox reaction. It's basically an acid-base reaction. Okay, let's move on to question 31. Okay, let's move on to question 31. So in question 31, we are told that starting in April 2023, a record-breaking heat wave has affected many Asian countries. Okay, then scientists have largely attributed this to worsening global warming due to rising amount of greenhouse gases, mainly carbon dioxide and methane. Which actions correctly impact the amount of greenhouse gases in the air? So in other words, they are asking you, what's the impact of each of it? Does it increase or decrease the amount of greenhouse gases? So increased population of cattle, when you have more cattle, there'll be more methane produced, and at the same time, there'll be more carbon dioxide being produced. So A is wrong because the amount of carbon dioxide should also increase. Increased use of electric cars, they say that it increased carbon dioxide, decrease methane. If you use a cleaner form of energy source, okay, the amount of carbon dioxide will decrease. Okay, then so this is wrong. Reduce deforestation. When there's less deforestation, that means you have more trees, you will decrease the amount of carbon dioxide, but the trees do not affect the amount of methane, so it's negligible. So C is correct. D, reduce ocean size by land reclamation. Land reclamation typically will produce a lot of carbon dioxide, so the amount of carbon dioxide should increase, so D is wrong. So the answer is C. Moving on to question 32, recent surveys suggest that 4% of the lakes in Sweden and Norway are essentially dead and contain no fish as the pH of the lake water drops to 4 and lower. So which gases are likely to the likely contributors to these environmental consequences? So the pH is 4 and lower, that means it is acidic. So when we are talking about acidic, so we need to look at acidic substances. So which gases are likely contributors? So chlorofluorocarbon, CFC, and ozone, they are not acidic, so A is not the answer. Methane is not acidic, neither is carbon monoxide. Nitrogen dioxide is, when it dissolves in water, it forms nitrous acid. Sulfur dioxide, when it dissolves in water, it forms sulfurous acid. So these will make the water acidic, so the answer is C. Unburnt hydrocarbons and carbon monoxide, these are neutral, so they do not make the pH, or they do not drop the pH of the water. So the answer for 32 is C. Moving on to 33, which statement about polyunsaturated vegetable oil is correct? So you have unsaturated, so that means it contains double bonds or multiple bonds. Okay, so it has double bonds between carbon and hydrogen. This is wrong. Hydrogen and carbon cannot form double bond because hydrogen only has 1 electron. So it cannot donate 2 electrons for the bonding. So hydrogen will never have double bond. Okay, so it's carbon-carbon double bond, not carbon-hydrogen double bond. So A is out. B, it reacts with hydrogen to form a solid compound. Yes, vegetable oil, it undergoes hydrogenation. That means it reacts with hydrogen to form margarine, okay, which is a solid. So this is correct. It reacts with steam to form margarine. No, it's hydrogen. It turns aqueous bromine from colorless to brown. No, it turns aqueous bromine from brown to colorless. So alkenes, the alkene or the CC double bond present in polyunsaturated vegetable oil will be able to decolorize bromine. So it turns from brown to colorless. So D is also wrong. So the answer is B. 34, octane is produced in the petrol fraction using fractional distillation of crude oil. So you have fraction 1, petrol, and fraction 2. So basically, this one is your different fractions in the fractional distillation of crude oil. So you just need to memorize them. Which statement describes the fraction just above and below petrol? So the fraction that is above petrol, okay, contains only methane. No, it is always going to be a mixture. So it is not pure. All the fractions here, okay, are all mixture of different type of hydrocarbons. So they have quite a similar range in boiling point, but they are not the same compound. So it's always a mixture. So each fraction is a mixture. So it cannot only contain methane. So A is not correct. B, fraction 2 is commonly used as lubricant. So no, it is not. Fraction 1 has the lowest boiling point. Definitely, this is correct. Fraction 2 is the most flammable. No, the most flammable is fraction 1. So wrong. So the answer is C. Question 35. A mixture of 10 cm³ of propane and 10 cm³ of propene is burnt in 100 cm³ of oxygen. The resultant mixture is then cooled in to room temperature. Which statement about the reaction is correct? So let's first write out the equation. So I have propane, which is C3H8. Okay, it undergoes combustion, so it reacts with oxygen to form carbon dioxide and water. So we'll need to balance that. I know it's 3 CO2 because there are 3 C's here, 4 H2O's to get 8 H. So once I have that, I need 5 oxygen here. So if I have 10 cm³ of propane, I'll need 50 cm³ of oxygen and I'll form 30 cm³ of carbon dioxide. I ignore water because water is going to be a liquid. So your mole ratio is only equals to volume ratio for gases. It does not apply for your gases. Sorry, it doesn't apply for your liquid. So only for gases. So because H2O is a liquid while the rest are gases, so we cannot use the volume the mole ratio goes to volume ratio for H2O. Now let's also write out the equation for propene. Okay, so we have 3 CO2 plus 3 H2O. Okay, so we have 4.5 H2O2. So I know that if I have 10 cm³ of C3H6, I need 45 cm³ of O2 and I've produced 30 cm³ of CO2. So 30 plus 30, 60 cm³ of carbon dioxide is produced, correct? The resulting mixture contains carbon dioxide and water only. So I started off with 100 cm³ of oxygen. I only used 50 plus 45, which is 95 cm³ of oxygen. I still have 5 cm³ of oxygen left. So the resultant mixture will contain carbon dioxide, water, as well as the unreacted oxygen. So 2 is wrong. Next, 10 cm³ of propane requires 20 cm³ of hydrogen to be converted to propane. So let's look at this. So if I have propane, which is C3H6, okay, it will react with just 1 mole of H2 to form C3H8. And because they are all gas, volume ratio equals to mole ratio. If I have 10 cm³ of propene, I'll need 10 cm³ of hydrogen, not 20 cm³ of hydrogen, because the mole ratio of C3H6 to H2 is 1:1. So 3 is also wrong. So therefore, only 1 is correct, and the answer for 35 is A. Moving on to 36, which row correctly describes the type of reaction taking place? So this C4H8 plus H2O, you form C4H9OH. It is basically your alkene react with steam. So it's a hydrolysis reaction or an addition reaction. So this is wrong. The C6H12O6, it's your glucose. Okay, you get C2H5OH plus 2 CO2. This is fermentation, correct? Okay. So you have your glucose breaks down to ferments to form ethanol and carbon dioxide. This is fermentation. So B is correct. C4H10, if you look at the formula, it follows the general formula CnH2n plus 2. So this is an alkane. Alkane plus bromine. So this is a substitution reaction. Okay, in the presence of UV light. Okay, another reason why we know is not addition but substitution is because you form 2 products. Okay, if it is an addition reaction, only 1 product is formed. So this is not addition. Next, condensation reaction. That means you will give us small molecules like H2O, HCl. Okay, so your esterification is a condensation reaction. Okay, your C10H22 forms C5H10 plus H2. This is cracking. Okay, so your big molecules break down to form small ones. So this is cracking, it's not condensation. So the correct answer for 36 is B. Moving on to 37, organic compound P, Q, and R have an empirical formula C2H4O and are isomers of one of the following. Okay, further chemical tests are carried out and the results are shown. Okay, so of, so PQR, they are both C2H4O and they're isomers of one another. So we know that P and R are soluble in water, okay, but not Q. None of them so only P reacts with sodium carbonate but not Q and R. Then only R can be oxidized by acidified KMNO4. So we know that C2H4O, it has one oxygen, so very likely you only learn a few, right? You only learn alcohols, alkane, carboxylic acid, esters. For esters and carboxylic acid, they need 2 oxygen. Okay, because of the functional group. The functional group of carboxylic acid is COOH. Once you have COOH, you have 2 oxygen, right? Esters, you have COO something something. You also have 2 oxygen, so they need 2 O, right? Okay, but then we know that this is the empirical formula, C2H4O. So if it is an ester or an carboxylic acid, it should be C4H8O2, something like that. Okay, so now let's first, before we go on, let's first look at this. Solubility in water. Q is not soluble in water. Okay, then next, P can react with Na2CO3, so it's an acid. So we know that P is an acid. An acid, a carboxylic acid cannot be acidified by KMNO4. And a carboxylic acid is going to be soluble in water, so P is a carboxylic acid. Okay, so C and D are out. Next, let's look at Q. It is not soluble in water. It doesn't react with carbonate. It does not get oxidized. So very likely, cannot be oxidized means not an alcohol, right? Okay, so this is out. So very likely it's an ester, because esters, it is insoluble in water. It doesn't react with carbonate because it's not an acid. It cannot be oxidized. Okay, so very likely the answer is B. But let's check R. So we say that R is an alcohol. Is it true? It's soluble in water. Yes, alcohols are soluble in water. Alcohols do not react with carbonate. Alcohols can be oxidized by acidified KMNO4. So the answer is B. Okay, next, dichloroalkenes are often used as industrial solvents to remove paints or furniture. One such compound has the following structure. Which structure below is not an isomer of the compound shown below? So to do this question, let's look at what are isomers. Isomers basically have the same formula but different structural formula. Okay, so they have 2 Cls, right? So if I look at it, all of them have C3, 2 Cls, 2 Cls. Okay, and 1, 2, 3, 4, 5, 6, 6H. So all of them have 6H. So they all have the same formula. So if we say that it's not an isomer, that means they have the same formula, right? But they need to have different structural formula. In other words, they have the same structural formula. So which one is it? So let's take a look at this. For this type of question, you look at where the chlorine is bonded. So for this compound, the chlorine is bonded at the first and the second carbon. Okay? So we count the first carbon as the one that has Cl. So this, we'll count this as the first, because we can count first here, we can count first here. So we always count 1 to the one that has Cl. Okay, so this C1 has 2 Cl. This Cl is on first and second carbon, so they have different structure. So this is an isomer. Okay, next, this one and this one both have Cl. So I can count this as the first, I can count this as the first, it doesn't matter. So this so the Cl is on the first and third carbon. This Cl is on the first and second carbon, so they have different structure. So therefore B is also an isomer. Okay? Because they have different structural formula. Next, the Cl starts from here, right? So this is the first, second, and third. So the Cl is bonded to the first and the second carbon. So this Cl is also bonded to first and second carbon. So they are the same structure. So isomers must have different structures. Okay, so they are the same. So therefore C is the answer, because they are exactly the same molecule. Okay. Okay, if you look at D, so I can name this 1, 2, and 3. 2 Cls are bonded to carbon number 2, which is different because from here where the Cl is bonded to the first and second carbon. So because they are different, they are isomers. So the answer for 38 is C. Moving on to 39, ethanol chloride reacts readily with ethanol to form ethyl ethanoate as shown in the reaction below. What is the molecular formula of the compound formed when propanol chloride reacts with methanol? So if you have propanol chloride, so instead of having CH3, it just becomes CH3CH2, right? Reacts with methanol. So instead of having CH3CH2, now you have CH3OH. Okay, so if you look at this, right, so let's first look at this. Let me call back here. Notice that this is a HCl that's being formed. So essentially, I just take this away, and I join it from here, right, to form this compound here. So this C here is joined to this O, then followed by CH2, then CH3. Okay, so now if I were to change ethanol chloride to propanol chloride, so now I know that it's no longer CH3, it's CH3CH2. Okay, then methanol is not CH3CH2OH, it's CH3OH. Okay, so in other words, instead of having CH3 here, here becomes CH3. Instead of having CH3 here, it becomes CH3CH2. So now let's count the number of carbon 1, 2, 3, 4. So this product here, which is going to be called propanol methanoate, we'll have 4 carbons, 1, 2, 3, 4, 4 carbons, C4. Then the number of hydrogens will be 3 plus 2 is 5, 5 plus 3 is 8. Okay, then next O2. So it's C4H8O2. So C4H8O2. So the answer is D. So for 39, the answer is D. Coming to this question, X and Y are two commonly used biodegradable polymers. X has a similar structure to nylon 6. So in other words, we know that nylon 6 has an amide linkage, and an amide linkage is CONH. Okay, so this is out. This is additional polymer. Both of these are amide linkage. This one is ester linkage, so D is also out. So we are only left with B and C. Next, Y has a structure similar to pterylene. So pterylene has ester linkage. And ester linkage looks like this, COO. Okay, so you look at this, COO. Okay, correct. This one, amide linkage, so this is out. So the answer is B. So which row shows polymer X and Y? That will be row B, and the answer is B.